Let's practice a few problems that use the product rule and the quotient rule and the power rule for logs. So these two problems are going to say expand. They're going to start with one logarithm and we'll end up with multiple logarithms. And then the third problem is going to say write this thing that has 3 logs as a single logarithm and simplify. But first off, I just want to make clear, these are the rules we're using. It's kind of important to know those rules in general, but it's way more important to actually be able to use them. So some people, they spend a lot of time memorizing those rules, but they can't use them, and that's a real problem. So let's come here and let's try and use it. Notice this 4 and this x squared are multiplied in the numerator, right? So what's that mean? That means we can break that apart using the product rule, okay? So that's log base 2 of 4 plus log base 2 of x squared, okay? And then it's divided by the square root of y. So now I'm going to put minus log base 2 of square root of y. Makes sense? So I've just used the product rule in the numerator and the quotient rule. So multiplying 2 inputs is the same as adding their outputs. Then dividing by this is the same as dividing their outputs. Sorry, subtracting their outputs. Okay, so how do I simplify this? Now, there's 3 different pieces, and so I can still expand a little farther. And let's see, log base 2 of 4, 2 to what power is 4? Since that's all numbers, I can say, well, 2 squared is 4. That's actually equal to 2. What about this here? I have an exponent, x squared. Using the power rule, I can write that as 2 log base 2 of x, okay? What about this last one? That has a power to the 1/2. So I can write that as 1/2. That's about as expanded as you're going to get, okay? How about this one? Notice this is fairly similar in the sense of it's a log base 10, so I don't have to put a log there, right? Log square root of 10, okay? That's times this next piece. So multiplying the inputs is adding the outputs, x plus y to the second, okay? Now, you might say, I want to pull those apart. Well, there is no rule for adding inputs. Just like, you can't break a square root across a plus or a minus. You can't break a log across a plus or a minus. See, all of these rules for breaking things apart, if you have a power on the inside, if you have a product on the inside, a division on the inside, you can break them apart. Same thing for a power, right? Because log's really the undoing of powers. But there is no way to break that apart. We're not going to break apart the x plus y on the inside. Same for minus. And just like the last one, since we're dividing by x to the 6th, I'm just going to write log of x to the 6th. Dividing the inputs is the same as subtracting the outputs. Well, hopefully, and in fact, you could even pause this and try and do the next step yourself. The next step is pulling those powers out. So this is 1/2 log of 10. Now you might say, I know that log base 10 of 10 is 1. So you could just write that as 1/2 times 1 right now, but I'm going to wait till the next step. Plus 2 log of x plus y. You need that parentheses. That's all in the input. Minus 6 log of x. Okay, and then as we mentioned, this last piece can just be simplified to 1/2. Oops, I missed my minus sign, my equal sign, plus 2 log of x plus y minus 6 log of x. Okay, so now you can use these rules from one direction, one side to the other, or you could go in reverse. Theoretically, you could take the right side of this and get back to the left. And that's what we're supposed to do here. Well, first off, we're going to have to get those coefficients in front inside. So we got log base 7 of x squared, right, minus log base 7. By the way, I should say, do you see that these are all log base 7. And this is a typo. I'm sorry. If they aren't all base 7, you can't combine them. All of the rules here have the same base. If they don't have the same base, as that problem didn't initially, but we're going to change the problem so we can combine them, then they can't be combined. Okay, so first off, we're going to take the powers in front and we're going to pull them out. So I'm going to write what would happen if I took xy to the third. Well, that's really x to the third, x to the third, y to the third. You know, you can write it as xy parentheses to the third, but the point is the entire thing's raised to the third. Then plus log base 7 of y to the, and you can write to the 1/2, you can write to the 0.5. I think I'll just do 0.5. Now, the thing that's subtracted is going to end up in the denominator. So if you want to, what you can do is you can just write that in the denominator. You could also, incidentally, you could also have treated this last line as a -3, add it, and just put a -3 in these exponents. That would have the exact same effect, remember, because what's a -3 do? A -3 just puts something in the denominator. Okay, so I'm putting it all together, hopefully. Let's see how that works. Equals, okay, log base 7. I'm going to use the quotient rule to say, hey, it's x squared over the quantity x to the third, y to the third, right, times y to the 0.5 or y to the 1/2, right? That's just what we got there, okay? Now, all of that is supposed to simplify. Notice we've got a bunch of powers, and so we're just going to use the rules for exponents. I've got an x squared over an x to the third. That's 2 minus 3, that's -1 plus 1/2. That ends up with, oops, no, these are the only x's. So that ends up with x to the -1. Sometimes people will say write it with only positive powers. That's fine too. I'll show you that as well. And then I have y to the 1/2 divided by y to the third. That's y to the -2.5. So if there weren't any instructions as this one, there's not, you could just write it like that. That's perfectly acceptable. Or if you wanted to write it with positive powers, sometimes people instruct you in a problem to write it with positive powers. You write x to the 1 times y to the 2.5. And notice I've now written it with positive powers. Okay, so I hope that's helpful to you, and we'll let you take it from there.